So what was the last point? I think we have discussed reflection of wave last time. How does a transverse wave gets reflected from rear and rigid boundary? What happens to the crest? What happens to trough? So whenever it is a rigid boundary, it will change the phase by amount equal to pi. So at the rigid boundary, there will be destructive interference between incident wave and reflected wave. So crest will be reflected as trough, trough will be reflected as crest. If it is a rear boundary, crest will be reflected as crest, trough will be reflected as trough. At the rigid boundary, compression is reflected as compression, and rarefaction is reflected as rarefaction. Yes or no? And at rear boundary, compression is reflected as rarefaction, and rarefaction is reflected as compression. At the rear boundary, rarefaction is reflected as compression, compression is reflected as rarefaction. These are the things we have discussed last time. Next, let us try to understand the reflection of reflection and transmission of waves when there are two strings. When there are two strings. So let's say this is a lighter string, means having lesser mass per unit length. This is a lighter string. On the lighter string we have the crest. So comparatively this is the rigid boundary. So you will have a reflected wave, but it will be having a trough like this. And some part of this incident wave will be transmitted as it is. Reverse, if we have a heavier string means more mass per unit length, it collides with this, or the crest on the lighter string collides with crest on the heavier string. Incident wave is in the denser medium and it hits the rarer medium. Then crest will be reflected as crest, and some part of this incident will go onto the next string as a transmitted wave. Okay. Now what you have to understand is this. If the equation of incident wave is written like this, a sin omega t minus k1x. Here, equation of reflected wave is AR. AR means amplitude of reflected wave. AI means amplitude of incident wave. Here you can see K1. Here also you have to write K1. Here also you have to write K1 because medium is not changing. K is 2 pi by lambda. Decision of lambda will be taken by the medium. And you can observe the phase change of pi because the second medium was a denser medium. So incident wave will undergo a phase change of pi. What about transmitted wave? A sin omega t minus k2. That's it. No phase change. For transmitted wave, there is no change in phase. So don't write plus pi minus pi. And you can see only change is this k. K is not k1 now. It is k2 because medium has changed. That is the only change. One more thing that you have to notice, in the reflected wave you have the sign plus. In the incident wave the sign was minus, means wave was traveling towards positive x. Here wave is traveling towards negative x. Apart from that, the phase change of pi. And here the minus sign remains as it is. What does that mean? It means wave keeps on traveling in positive x direction. Similarly here, this is incident wave. Minus sign means it is traveling towards positive x. This is reflected wave. You can see only sign has been changed. Instead of this minus, they have written plus. K1 also remains equal to K1. K1 also remains equal to K1. Medium remains the same. No extra phase has been added or subtracted because the second medium is a rarer medium. So there will not be any change in phase. So whenever there is reflection from the rigid boundary, there will be change in phase. Otherwise, no. Okay. Now what about the transmitted wave? You can see the amplitude of transmitted wave. There also no extra phase is added. Of course, in transmission, no change in phase takes place. Also, the sign remains intact. This minus indicates that this wave keeps on traveling in positive x direction. So if you create a pulse on the lighter wave, after some time you will have two pulses like this. And if you create pulse on the heavier string, lighter string, heavier string. If you create pulse on the heavier string, that pulse on the heavier string will hit the lighter string, and after some time, final situation will be this. Okay. Let us try to understand mathematics behind this. Can I write incident power is equal to reflected power plus transmitted power? I can write incident power is equal to reflected power plus transmitted power. Now what is power? Total energy per unit length, rate of transmission of total energy. Rate of transmission of total energy. Now to find rate of transmission of total energy, first find total energy per unit length into the velocity. We know total energy. Total energy means 1/2 m omega square a square. But total energy per unit length will be, instead of m, it will be mu omega square a square into velocity. So this is what? Power of a wave. You can see the formula. So incident wave is in the medium 1. So incident amplitude and medium 1. Frequency remains same. Frequency of the wave is decided by the source and not by the medium. So don't write omega 1 and omega 2. Now, this is amplitude of incident wave, velocity in the first medium, mu, mass per unit length of the first medium. This reflected wave is also in the first medium. So we will not change mass per unit length and velocity. It will remain mu1, b1. What will change? Only amplitude of reflected wave. This part will only change. And what about transmitted power? Yes, we have to change this mu. Now the medium changes. It becomes second medium. The transmitted wave is in the second medium. Incident wave and reflected wave are in the first medium. So 1, 1. But transmitted wave is in the second medium. And of course, amplitude of transmitted wave. So if you solve this, you will get this equation. So this is first equation in the two unknowns. What is the first unknown? Amplitude of the reflected wave. What is the second unknown? Amplitude of the transmitted wave. These are the two unknowns. The second thing, as per the superposition principle, I can say that the left hand limit of the displacement at the junction is amplitude of incident wave plus amplitude of reflected wave, and right hand limit of the displacement is amplitude of the transmitted wave. काल बोल रहे अपन displacements of the junction because of the incident wave plus reflected wave is equal to displacement of the junction point because of the transmitted wave. Now those displacements can be written as maximum displacements also, no problem. So this is second unknown in the same this is second equation in the same two unknowns. What are the two unknowns? AI and AR. These are the two unknowns. Clear? If you solve this, you will get this. The amplitude of the transmitted wave is this. Now don't say some fraction of incident amplitude. because this 2v2 can be greater than v1 plus v2, or this 2v2 can be less than v1 plus v2. So this may not be a fraction every time. So transmitted amplitude is not some fraction of incident amplitude. That fraction concept is not applicable for amplitude. That fraction concept can be applied to energy or the power. Out of the incident power, some fraction of power will be reflected and some fraction of power will be transmitted. Do you understand this? Incident energy is reflected and transmitted. So some part will be reflected, some part will be transmitted. There will be fraction. तिथं फ्रॅक्शनची कन्सेप्ट असेल. Here for amplitude don't say fraction. Amplitude of reflected wave is equal to this times this number. Now this has to be a fraction. Subtraction of two numbers will be always less than addition of same numbers. The interesting part is this fraction can be negative also, depending upon whether second medium is rigid or not. If second medium is rigid or denser, let's not say rigid and non-rigid, let us say rarer denser. If the second medium is denser, in the second medium you will have less speed. V is equal to what? Under root T by mu. Denser medium will have more value of mu, so it will have less speed. If the second medium has less speed, the subtraction will be negative. Amplitude of the reflected wave will be negative of amplitude of incident wave. It means this, that negative sign takes account for this extra pi. फेज डिफरन्स होतोय एक्स्ट्रा पाय. पाय ॲडिशनली फेज जी आहे इन्सिडेंट वेव्हची ती किती अमाऊंटने चेंज होते? पायने चेंज होते, मग ती बनते तुमची रिफ्लेक्टेड वेव्ह. No, coefficient of reflection. Coefficient of reflection means power reflected upon power incident at the boundary. When you try to calculate coefficient of reflection, reflected energy upon incident energy, total out of total energy, what part of energy is reflected? You can say energy or power. And you know power is proportional to amplitude square. Power is proportional to amplitude square, or energy is proportional to amplitude square, provided velocities are same. ही जी power आहे incident power, you can check incident power and reflected power. हे दोन्ही डिवाइड करायचे. This part divided by this part. दोघांसाठी medium same आहे. Incident wave and reflected wave, they have same medium. So mu will be same, omega already same, velocities are also same. So what remains is this amplitude of reflected wave, amplitude of incident wave. So power reflected upon power incident is amplitude of reflected wave upon amplitude of incident wave bracket square. So amplitude of reflected wave upon amplitude of incident wave ब्रॅकेट स्क्वेअर. म्हणजे या सगळ्याचा काय होणार आहे? स्क्वेअर होणार आहे. तो इथं झालेला आहे. ओके. आणि कोएफिशियंट ऑफ ट्रान्समिशन करताना काय केलंय? पॉवर ट्रान्समिटेड अपॉन पॉवर इन्सिडेंट. आता पॉवर ट्रान्समिटेड आणि पॉवर इन्सिडेंटचा जर विचार केला, दिस इज पॉवर इन्सिडेंट and this is power transmitted. You cannot simply take ratio of amplitude squares. Yes, powers are proportional to amplitude squares, but the problem is mediums are different. So here you have to take into account this mu1 v1 and this mu2 v2 also. So power transmitted upon power incident is equal to, what is power transmitted? This mu2 80 square v2, mu2 80 square v2 divided by mu1 ai square v1. Now you can replace this mu equal to under root t by mu, sorry, not this, This V is equal to what? Under root T by mu. So mu is equal to what? T by V square. So mu1 is T1 by V1. No need to say T1, T2. Both these strings are in series. So tension has to be same. So mu1 is T by V1 square. Mu2 is T by V2 square. If you do that, you will get this. And if you solve this, you will get ratio of transmitted amplitude square upon incident amplitude square. Now this transmitted amplitude and this incident amplitude and this bracket has to be squared. But again that bracket has to be multiplied by this V1 by V2. So you will get coefficient of transmission also. So तुम्हाला coefficient of transmission मिळेल. Now to summarize, basically it is this. It's not hard, it's very easy. What are the things that we shall remember here? The first thing that we can write is about power. Incident power is equal to reflected power plus transmitted power. Power is equal to what? Total energy per unit time. Total energy per unit time means what? Total energy per unit length into velocity. What is total energy per unit length? 1/2 mu omega square a square into V. Incident wave is in the first medium. So this is amplitude of incident wave and this is velocity in the first medium. In the second medium, in the second string, you have this transmitted wave, but this reflected wave is again in the same medium. So 1/2 mu omega square a square V, 1/2 mu omega square a square V. Reflected wave is also on the first medium, but only here change is AR. Here AT. Medium changes. So V2 and this mu can be replaced as under root, not under root. V is under root T by mu. Mu is T by V square. So T same. So mu2 is T by mu2 is T by V2 square and this mu1 is T by V1 square. So you will get first equation between this incident amplitude, reflected amplitude and transmitted amplitude. So it is this incident amplitude square upon V1 is equal to reflected amplitude square upon V1 plus transmitted amplitude square upon V2. AT square upon V2. This mu2 into T2. This mu2 into V2 comes out to be T upon V2. ते सगळे T cancel होतात upon V2 शिल्लक राहतोय. So this is first equation and the second equation is AI plus AR is equal to AT. Displacement of the junction from the left hand side because of the left hand side waves and displacement of the junction because of the right side wave. Left side wave and right side wave. So this is two equation, two unknown game. So amplitude of the transmitted wave पहिल्यांदा काढायचा. That is equal to some factor multiplied by amplitude of incident wave and amplitude of reflected wave will be some fraction. इथं मात्र fraction आहे. Some fraction of incident wave. इथं fractionच आहे. इथं fraction नाहीये. This amplitude of the reflected transmitted wave can be greater than the incident or less than the incident. So let us write here 2v2 upon v1 plus v2. इथं बघा 2v2 upon v1 plus v2 आहे आणि इथं मात्र काय होतं? It was v2 minus v1 upon v2 plus v1 or v1 plus v2, doesn't matter. Now coefficient of reflection is easy to calculate. What is coefficient of reflection? The coefficient of reflection is power reflected upon power incident. But for reflection and incidence, medium remains the same. The reflected wave and the incident wave both are in the same medium. So you have to consider only this amplitude So amplitude of reflected wave upon amplitude of incident wave, bracket square. Now that ratio, amplitude of reflected wave upon amplitude of incident wave, that ratio is already available here. So what is your answer of coefficient of reflection? It is V2 minus V1 upon V2 plus V1 whole bracket square. Now coefficient of transmission, we assume that no absorption takes place. We know coefficient of absorption plus reflection plus transmission is equal to 0. That absorption coefficient we are taking as 0. So only reflection and transmission is taking place. So if you add these two R and T, you should get 1. Te yete 1. So the second option to figure out this transmitted coefficient of transmission is 1 minus R. 1 minus R केलं तरी answer येते. If you don't want to do that, what you can do is this. Coefficient of transmission is, you cannot simply take AT square upon AI square. Medium are different. And you know this mu2 can be replaced as T by V2 square. Mu2 is T by V2 square. So that V2 square and this V2 gets cancelled. So it is basically AT square, this part, AT square upon V2 upon AI square upon V1. It is this. So it is basically V1 by V2 multiplied by AT upon AI bracket square. Now AT upon AI, you know that amplitude of transmitted wave can be greater or less than this incident amplitude depending on the value of this V2. So it is 2V2 upon V1 plus V2 whole bracket square. If you solve this, what will you get? This 2 square is 4. This V1 as it is. This V2 square upon V2 is 4V1 V2. So you have to remember only this V2 minus V1 upon V2 plus V1 bracket square, and here 4V1 V2 upon, or you can simply write this as V1 plus V2. Sequence doesn't matter. So for coefficient of reflection, you have to write V2 minus V1 upon V2 plus V1 bracket square. Here 4V1 V2 upon V1 plus V2 bracket square. If you add these two, coefficient of reflection and coefficient of transmission, you will get 1. We have taken this coefficient of absorption to be equal to 0. कळलं का बघा? हे सगळे फॉर्म्युले लक्षात राहतील का बघा? हे नाही लक्षात ठेवलं तरी चालेल, हे नाही लक्षात ठेवलं तरी चालेल. या दोन इक्वेशन्सचा यूज करून हे आपण amplitude of transmitted wave काढलं, amplitude reflected, हे रेशो जर समजून घ्यायचे असतील तर हे इक्वेशन समजलं पाहिजे. कारण दिस इज पॉवर रिफ्लेक्टेड अपॉन पॉवर इन्सिडेंट. V1 ला V1 कॅन्सल होतोय, पण पॉवर ट्रान्समिटेड अपॉन पॉवर इन्सिडेंट करताना V2 ला V1 कॅन्सल होत नाही. ते राहतात शिल्लक. कळलं का बघा?
तर कोएफिशियंट ऑफ ट्रान्सलेशन मध्ये 4V1 V2 अपॉन V1 प्लस V2 ब्रॅकेट स्क्वेअर पाहिजे ना, वरती स्क्वेअर नाही येणार.
कोएफिशियंट ऑफ
ट्रान्सलेशन मध्ये खाली फक्त V1 प्लस V2 ब्रॅकेट स्क्वेअर पाहिजे.
हा बरोबर. इथं जे होणार आहे ना, इथं काय झालं, एक स्क्वेअर केला होता न्यूमरेटरचा, डिनॉमिनेटरचा केला नव्हता, तो फक्त ऍज इट इज राहील. कळलं का बघा? हा स्क्वेअर केला होता, 4V2 स्क्वेअर केलं होतं, तो V2 स्क्वेअर आणि हा V2 कॅन्सल केला होता, हा केला नव्हता, तो ऍज इट इज राहील. असं होईल 4V1 V2 अपॉन V1 प्लस V2 ब्रॅकेट स्क्वेअर असं होईल. सो जे इम्पॉर्टंट फॉर्म्युले आहेत ते एवढेच आहेत. कळलं? दीज आर दी थिंग्स, दॅट्स इट. ऑफकोर्स एवढा सिलेबस नाही आहे आपल्याला, बऱ्याच गोष्टी सिलेबस मधून काढलेल्या आहेत, बट स्टील वी आर लर्निंग देम. नेक्स्ट. Okay, this starts standing waves. आहे खाली आहे ते V1 प्लस V2 ब्रॅकेट स्क्वेअर. कळलं का बघा? सो आता 1 तासभर वेळ आहे. तुम्ही काम करायचं आहे वेव्हज वालं जे काय स्टँडिंग वेव्हच्या आधीपर्यंत जेवढं काय काय आहे. कुठल्या वेव्हज बघतोय आपण आता? प्रोग्रेसिव्ह वेव्हज. प्रोग्रेसिव्ह वेव्हज और ट्रॅव्हलिंग वेव्हज. त्याचे क्वेश्चन सॉल्व्ह करायला घ्या. नीट वाल्यांनी लास्ट स्टेप सॉल्व्ह करायला घ्या. जेई वाल्यांनी वेव्हची PDF ओपन करा आणि वेव्हचं सॉल्व्हिंग करा. 1 तास वेळ आहे. चालू करा. वेव्हज वाला जो चॅप्टर आहे त्याचं सॉल्व्हिंग आपण लेक्चरच्या टाइम मध्येच करू. चालू करा. नीट वाल्यांनी लास्ट स्लिप सॉल्व्ह करा. जेई वाल्यांनी वेव्हची PDF ओपन करा. असेल ना वेव्हची PDF तुमच्याकडे? ठीक आहे. तुम्ही लोकांनी मीटिंग एंड करून 1 तास सॉल्व्हिंग करा. सॉल्व्हिंग केल्यानंतर ग्रुपवरती मेसेज टाका किती क्वेश्चन तुमचे सॉल्व्ह झाले. ठीक आहे प्रत्येकानं? चालेल. ठीक आहे. 2 नंतरचा वेळ रिव्हिजनच्या सॉल्व्हिंगसाठी टेस्टच्या सॉल्व्हिंगसाठी वापरा. करंट चॅप्टरचा वेळ जो काय आहे तोच आपण लेक्चरचा जो वेळ आहे तोच आपण करंट चॅप्टरच्या सॉल्व्हिंगला यूज करू. 1 मिनिट पण वेस्ट करायचा नाहीये. न बोलता आपलं आपण सगळं सॉल्व्ह करा. ऑनलाईन लोक लेफ्ट झाले तर चालतील.